Good morning, Star People. On your screen is a live view of Starship awaiting its second integrated flight test from Starbase, Texas. If all goes well, our Starship spacecraft and the Super Heavy booster, which we collectively call Starship, will lift off together for the second time in just 33 and a half minutes from now. Thanks for tuning in. We're excited to be joining you from SpaceX headquarters in Hawthorne, California for today's flight test. Now, there's nothing quite like launch day, and especially so when it's a test flight. It just hits different. We're super excited to be here.
Exactly, Kate. And we're excited to be here to watch Starship, which is the latest and largest vehicle developed to date by SpaceX. And we're building it to fly exciting missions, to get massive payloads into orbit, to land astronauts on the moon for the first time in 50 years, and ultimately to get humanity to Mars.
But the fundamental revolution with Starship is that it's designed to be a fully, rapidly reusable, reliable rocket, or what we refer to as the 4 Rs. For those of you following along, you know all too well that Starship gave us quite a show during its first flight test back in April. After successfully lifting off and clearing the pad, Starship became the most powerful rocket ever launched.
But during the ascent, we had leaking propellant in the bottom of the booster, which led to sustained fires, loss of control, and ultimately a rapid, unscheduled disassembly. Of course, there's no test quite like a flight test, and our teams learned a lot, which began design changes and then ultimately hardware upgrades. That iterative approach is a big part of how SpaceX does development, and it's been the basis for all of our major innovations, including those on Falcon, Dragon, and Starlink.
I have to comment what gorgeous sunrise views we have here of Starship. Now, while that first flight ended in fireworks, it delivered valuable test data, which our teams have used to rapidly iterate on Starship's overall design, including significant upgrades to the ship, the booster, and the ground systems. Now, the most notable change is to the stage separation system, which will also be the most challenging part of today's test. We'll talk a little bit more about those updates a bit later in the webcast.
Now, in preparation for today's flight test, the vehicles have undergone dozens of individual tests, including a static fire on the ship, 2 super heavy static fires, and a final full wet dress rehearsal that we completed at the end of October, where we loaded the vehicles fully up with propellants and tested our new countdown sequences. And that brings us to these beautiful shots on today's flight test day. After 7 months of hard work by the entire SpaceX team, we're ready to give launch another shot.
100%. Now, once again, just like Flight 1, excitement is in the air. The electricity is certainly starting to grow. This is a live view of our Starbase Control Center, known as Star Command. It is 6 miles from the pad. We also have teams gathering here right behind us in Hawthorne, California at our Mission Control Center. You can see the crowd gathering. It is an early morning, but you got to wake up early to get that front row seat. And we also have public gathering on the beaches at South Padre Island, as you see there.
And I can't say this enough, today is a flight test. While it's not happening in a lab or on a test stand, today is absolutely a test. And the goal is to gain invaluable data to continue rapidly improving Starship. So whatever the mission outcome today, excitement is guaranteed.
Now, if all goes well, Super Heavy will fire its 33 Raptor engines and lift off from that pad right there in Starbase. About 3 minutes into flight, we hope to see the Super Heavy booster separate from the ship in SpaceX's first ever hot stage separation. This means that the second stage will light its engines while still attached to a partially lit booster. If the ship's engine's light, and if the whole thing holds together, its engines will remain lit for about 6 minutes before the coast phase.
Now, with those big ifs, if we get past a successful stage separation, the booster is going to perform a flip maneuver, then execute a boost back burn before it attempts a splashdown in the Gulf of Mexico. In the meantime, Starship will coast for about an hour at altitudes ranging between 150 and 250 kilometers before it makes its own re-entry into the Earth's atmosphere, and then ultimately a hard splashdown in the Pacific Ocean.
Now, again, if we get past a successful stage separation, Super Heavy will leave the ship at an altitude and trajectory just shy of orbital, meaning Starship won't have to fire its Raptor engines for a deorbit burn and will naturally come back into the atmosphere. Now, meanwhile, Super Heavy will attempt a landing burn before splashing into the Gulf. While the booster will practice a landing, we do not plan to recover any hardware from Super Heavy or the ship on this particular flight. Now, with the exception of Falcon, this really is no different than what happens to most other rockets flying today that are expended or fall into the ocean after completing their mission.
Now, even though we aren't planning recovery, the telemetry and data that we receive all the way to the end of today's mission is really what we're looking for, particularly with respect to temperatures during reentry and how the heat shield performs. Much like our first test, we want to gather as much data as we can around the fully integrated vehicle in this flight-like environment.
Exactly. So let's talk about some objectives for today. The primary goal for Flight 1 was to clear the pad. We did that, and we got amazing data that helped us to improve the vehicle and pad that you see right there today. This time, on Flight 2, we're hoping to get all the way through stage separation, where we will try to perform this hot staging maneuver. In the bigger picture, ascent is the most critical objective today, and everything else is learning. Like I said last time, a few times, the further we fly, the more data we can collect.
Now, we do expect that the camera views will be spotty after stage separation, and that's because we rely on ground stations that are positioned along the globe along the trajectory. But we are experimenting with Starlink on both the booster and ship on this mission, which will be communicating with our satellites in orbit to see if we can get that data.
Yeah, so if we make it past stage separation, there is a chance that we could get better live views throughout the duration of the flight test, including re-entry, where we typically have a blackout period with no communication with the vehicle whatsoever. So all that said, this is the first time that the vehicle will attempt to communicate with Starlink in orbit, so no guarantees.
Now, we're at T-minus 27 minutes, so let's check in with John for an update on the countdown. How are we looking, John?
Thanks, Shiva. We're currently loading propellant from the ground system into both the first and second stages, and we're on schedule for launch in just over 26 minutes from now. Now, we delayed a day getting here. Yesterday, on Friday, we had to replace a discrepant grid fin actuator on the first stage. We also replaced 2 other actuators as a precaution. The stages were remated, checked out, and everything was go for where we are right now this morning. Now, as I mentioned, we are in propellant loading. Both vehicles, the first and second stages, use the same 2 propellants. Our fuel is liquid methane at a temperature of just over 100 Kelvin, or about 272 degrees below 0 Fahrenheit. This is a different fuel from Falcon 9, where we use the RP1 kerosene. But our oxidizer is liquid oxygen, the same as Falcon 9. Because there is no oxygen in space to support combustion, we have to bring our own. We did the weather poll and the go-no-go poll at T-minus 2 hours. We got the goes, and we started loading both propellants on the booster at T-minus 1 hour and 36 minutes. And at T-minus 1 hour and 17 minutes, we began propellant loading of the ship, second stage. Propellant loading of the Starship second stage main tanks will complete at approximately T-minus 22 minutes, just a few minutes from now. And at about the same time, we will switch over to loading the header tanks in the nose of the ship. Meanwhile, it'll be T-minus 3 minutes when Super Heavy prop load completes on the first stage. And at that point, all propellant will be on the rocket, fully loaded with over 10 million pounds of propellant. As we near T0, it's worth noting that the timing of the countdown will be slightly different today. For Flight 1, we lit the engines and lifted off about 6 seconds later. For Flight 2, we aim to reduce that time by almost 2 seconds, shortening the period between engine start and liftoff. This will help reduce stress on the ground and the propulsion systems and improve the efficiency of the rocket. Now, right now, we're just inside T-minus 25 minutes to liftoff. The weather and winds are looking good. We haven't had any concerns there. The only issue we're working is getting the small boats out of the near range area in the offshore from Boca Chica Starbase. We do have the possibility of holding at T-minus 40 seconds as we're trying to get the last of the boats out of the safety area. Now, if for some reason we do not make our test flight today, we have a backup launch windows. This could be either 24 or 48 hours after today. It depends on how far we get into the countdown. But for now, everything's looking good as we've passed, coming up on the 24-minute mark. I'll hand it back to you, Kate and Shiva.
Thanks, John. Now, that countdown is continuing to progress, so let's take a look at and get more familiar with the vehicle there on your screen. Starship is the world's most powerful launch vehicle. It's currently currently with about twice the thrust of the Saturn V rocket, and with future engine upgrades, it will be 3 times more powerful. Those future improvements will allow Starship to carry 150 to 250 metric tons to orbit.
Now, for reference, Falcon 9's heaviest payload to date is about 17 metric tons. So we're talking about an order of magnitude more with Starship in terms of payload capability. And that matters because the amount of mass that we're able to launch per rocket is crucial to ultimately creating a self-sustaining city on Mars. Now, let's talk a little bit about how tall the vehicle is. The Super Heavy booster alone stands about 70 meters tall, and that's about the same height as a fully integrated Falcon 9. The height of Starship on top of it is comparable to that of the Statue of Liberty. But of course, the most technical length unit is that of Godzilla's, and we can confidently say that the fully stacked Starship and Super Heavy is at least 1 Mechagodzilla tall. It just so happens that we refer to the launch and catch tower at Starbase as the Mechazilla from the Godzilla movie, and you could see from that the resemblance is quite uncanny.
Very, very uncanny. Now, the first stage, also known as the booster or Super Heavy, has a diameter roughly 2.5 times that of Falcon 9, and with 33 much larger engines. More engines means more power to deliver a massive amount of cargo to space. Amazing view here. This is a view that we don't have on our Falcon 9 missions. This is a view looking up under the Super Heavy booster. I love the shot. We can see all 33 engines there. Now, one cool upgrade on the booster's engines, we have a new electronic thrust vector control system, or ETVCs. We previously used the hydraulic system to control the positioning of the Raptor engines, meaning we tilted them in flight using pressurized fluid. Now, hydraulics are complex, and because they're fluid-based, they have the potential to leak. Not good. So, switching to an electronic system means fewer potential points of failure. Also, we now carry less mass on the vehicle because we don't need to carry hydraulic fluids anymore. So, good news all around. Now, the electric system has lots of benefits on its own. It only takes 30 minutes to activate for flight. It doesn't consume resources when inactive, and they allow for regenerative charging like a Tesla battery.
Yeah, all great things when you're trying to rapidly reuse a vehicle. Now, moving up, Starship is designed for vertical takeoff and landing on any hard surface. That's opposed to taking off and landing on a runway like aircraft do. And that's important because there are no runways on the Moon and Mars. The ship features 6 Raptor engines, 3 of which are sea level, and 3 of which are vacuum engines with an expanded nozzle, which makes them optimized to operate in the vacuum of space. The ship, at the top of the ship is featured with 4 flaps as well. This is a shot actually of the top of the booster where we can see the hot stage portion and the 4 grid fins. Now, those flaps on the ship portion help aerodynamically control the vehicle's attitude during atmospheric reentry and flight, and will enable us to do precise landings. The body of Starship is also wrapped in a heat shield that's made up of 18,000 hexagonal ceramic tiles. You can see them wrapping around the top of the nose here and here in this shot of the flaps. Now, those tiles are designed to insulate the vehicle during atmospheric entry, where the temperatures can get as high as 1,500 degrees Celsius. And one of our test objectives today is to verify how those systems perform during reentry.
Yeah, now as Shiva mentioned, there between the ship and the booster, basically the top of the booster, between those 2 stages, that's our new hot stage, critical for our new separation technique. As we talked about earlier, we are constantly learning and upgrading the vehicle after we test. Now, this is a pretty exciting first for our team, as hot staging has never before been used as part of a reusable space transportation system, let alone on a rocket with the size and power of Starship. Hot staging is a significant change from Flight 1, and we're really hoping to gather data on it during this highly dynamic phase of flight, and that is, once again, assuming that we even make it that far.
Now, of course, let's take a closer look at what we expect hot staging to look like. Now, it occurs at about liftoff plus 2.5 minutes. At that point, the booster will shut down most of its 33 engines, leaving just 3 running, and the ship will ignite all 6 of its engines. clamps will release, and then the ship will thrust away from the booster. Now, this is the first in-flight test of the heat shield on the top of the booster and the bottom of the ship, and of course, the first in-flight test of hot staging, and we're hoping to gather a ton of data on it today.
Yeah. Now, stage separation by hot staging is somewhat uncommon in spaceflight, but it has been done before. However, today will mark the first time that a reusable space transportation system is attempting it. The Titan program did hot staging quite successfully in the early 1960s, but they were not concerned with reuse, so there was no issue when the Titan first stage took considerable damage upon ignition of the second stage engine. Now today, there is a good chance that our booster will also incur some damage from the second stage engines, but we need to test it out, see if the system can tolerate it, and collect data to learn how to do hot staging better next time, because ultimately, when successful, it could increase Starship's payload to orbit capacity by 10%. So more payload and more people to Mars. Hot staging also helps us maximize the vehicle's performance by leaving those three first stage engines on, so gravity can't rob us of precious velocity, or at least not as much of it. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the prop tanks, which is where we need that propellant to be in order to quickly light the ship's engines. Another reason to do hot staging, it reduces the risk at stage separation by moving to a passive stage system, deleting parts and simplifying, meaning physics is going to be doing most of the work instead of mechanical parts that would otherwise be pushing the two stages away from each other.
That's a great summary, Kate. And of course, this required design changes from Flight 1. The most notable of which is the interstage here. So on Flight 1, that interstage was completely enclosed. But for hot staging, the interstage portion between the booster and the ship is going to see dramatic increases in pressure and temperature. So we had to change the structure to include vents for the exhaust gases that the ship's Raptor engines will produce. Now, the three center engines on the ship actually gimbal, they rotate, and we're going to be gimbaling them outwards to reduce the forces that are being directly imparted on the booster and maximize the exhaust gas that's going through those vents. We've also beefed up the ship's space heat shield to withstand the higher temperatures and pressures. And for today's test, like really getting through hot staging would be a major milestone. There are some risks associated with this test, but of course, the ship and booster are going to be pretty far out over the ocean in the safety zone and far away from people.
Yeah, regardless of what happens, it's going to be super exciting to watch. Now, in addition to the first and second stages of the vehicle, Starship has a third stage that we call Stage 0. This consists of the launch mount, the tower, and the tank farm, all of which you can see there on your screen, as well as the pad infrastructure built around the rocket. Fun fact, it's the Guinness Book of World Records holder for the largest launch tower in the world. What a beautiful drone shot that we have here. Also important part of the system, but less visible right now, especially because of the fog, is our new water-cooled steel flame deflector, and that's certainly a new upgrade for this flight.
Yeah, on Flight 1, the Starship's launch pad was damaged pretty significantly during liftoff as those super heavy Raptor engines fired their full thrust into the foundation for more than 12 seconds. So now we have a new high-pressure, water-cooled steel flame deflector system that we developed and installed between the flights, and there you can see the video of it dispensing 260,000 gallons of water. And that's designed to dissipate those loads from the Raptor engines and support rapid turnaround of the launch pad with minimal refurbishment between flights. Part of a rapidly reusable launch system also means the pad infrastructure.
Yeah.
We've performed multiple standalone tests and have used this new system for both the Flight 2 booster static fire tests. And we've also reinforced the pad pretty significantly from Flight 1.
Yes. Now, also part of Stage 0, we mentioned before, the launch mount. Kind of hard to see there, but it's what the booster is connected to. Oh, here we can see basically the legs of the launch mount. This is what holds Starship and all of its mass. It holds Starship during ignition, right there at the Super Heavy booster. This is what houses all of the equipment needed to fuel the Super Heavy booster and condition it for flight, as well as all of those electrical, communication, and data connections between the ground and Starship. Bottom line is, it's an important part of how we talk to Starship on the ground and understand that it's really ready to fly.
And of course, the awesome camera shot there of those 33 Raptor engines.
Such a great view. We
Yeah.
don't have that view for Falcon 9, so I
wish we did.
love that we get it here. Now, as we mentioned earlier, the real game changer with Starship is not only mass to orbit capabilities, but that it's designed to be used over and over and over again with little to no downtime in between. Full and rapid reusability is the key to making routine space travel a reality, and SpaceX has been working on this since its inception.
Yeah, with SpaceX's family of Falcon launch vehicles, which are the first and only orbital class rockets capable of reflight, we started that. And Starship is going to take this even further with a reusable first and second stage. Now, while most rockets are expended after their portion of the mission, SpaceX rockets land back on Earth and are quickly returned to our hangars to prepare to refly again.
Exactly. In fact, 90% of all Falcon 9 boosters that have flown this year have been reused, or as we like to say, flight proven. So while launching and landing rockets may seem routine today, this was not always the case. For those of you that have been following along since our early days, you know that it took us 4 attempts before we successfully launched our first rocket to orbit. Here you see our Falcon 1 Flight 4. 15 years ago in September, that vehicle became the first privately developed liquid-fueled launch vehicle to orbit Earth. If Falcon 1 Flight 4 had not succeeded, it would have meant the end of SpaceX.
And our first successful landings didn't come easily. We had to miss the target a few times before we ultimately stuck the landing. But each of these landing attempts, how to not land an orbital rocket, were teaching us what we needed to know in a flight-like environment to get that full picture of how all the systems interacted together.
Oh man, yeah, this is me trying to not get goosebumps watching this first drone ship landing. I hosted that webcast, and it was so exciting to see that iterative development approach that we took finally paid off after so many attempts of failing. Now that failure is expected to help improve future designs of our vehicles and systems. So fast forward to present day, we've landed F9 boosters over 245 times since our first reflight of an orbital class booster 6 years ago.
Yeah, and it really comes down to our design philosophy. If you're not failing in some way, then there's room to learn and push the design to improve. And failure doesn't just mean blowing up a rocket. It might be not being as efficient as we want to be or producing slower than we want to. So that approach has been the basis of how we've made all of our major innovative advancements.
All right, now Falcon 9 has certainly come a long way, and Starship will too. But as a reminder, today is a test. We really hope to get to stage separation, but any data received will help us improve. It's the second of many future flight tests of Starship before it becomes fully operational.
And these flight tests teach us about the limits of our design. They help us improve our understanding of the vehicle, and ultimately will help us to make Starship more reliable and rapidly reusable. So again, whatever the outcome and however far we get today, we can promise excitement. So why are we doing all of this? Why do we need a rocket this big, and why does it need to be reusable so quickly? And that answer goes back to SpaceX's mission, which is to make life multiplanetary.
We aren't just building a new spacecraft, we're changing what it means to go to space. By building the most powerful rocket ever flown and a ship designed to carry people, cargo, habitats, satellites, and more, we're unlocking a future where our dreams of exploration will no longer exceed our grasp. And this mission continues with flights like today's integrated test.
And these are flights where we're going to fail fast, but learn even faster, where each time we're going to try something new while flying something that we've improved. And ultimately, that's going to build up a fleet to fly early and often as Starship rapidly evolves to become more capable and more reliable.
The first stop is our nearest neighbor, with a surface that hasn't seen visitors in more than 50 years. Under Artemis with NASA, Starship will return people back to the moon. After those first expeditions, we'll be ready to fly more people along with everything that it takes to build a moon base. Think about that. Hardware that will enable us to live on another world is sitting on a launch pad on Earth right now.
And the moon is just the proving ground. When the time comes to make that leap to Mars, everything gets ratcheted up by orders of magnitude.
The logistics of supporting an entire city on Mars are daunting, requiring millions of pounds of cargo flown from Earth, spread out over thousands of launches. We just broke our own record for the number of launches in a single year, and we're going to break it again next year.
Now, in the years to come, Starship is going to dwarf those figures as we bring it online and truly make life multiplanetary. But for now, anyway, as the clock counts down to today's flight test, why don't we get another status update from John?
We're just over 9 minutes from liftoff as the countdown clock clicks to 0. Good news is teams aren't working any significant issues on the launch vehicle right now. Propellant loading is continuing on both the Super Heavy and the ship stages. Most recently, we began loading LOX and methane fuel into the header tanks on the Starship. And on the graphic on the left side of the screen, you can see up in the nose of the second stage, what we call Starship, are those 2 header tanks for fuel and liquid oxygen. Now that loading started at T-minus 24 minutes and will continue until approximately T-minus 5.5 minutes. Now Starship's second stage main fuel and LOX tanks are loaded for flight. And the second stage propellant that we're loading on board is going through the quick disconnect that comes out on the arm that's located at the base of the stage from the tower. Now on the Super Heavy booster, propellant loading will continue until T-minus 3 minutes. We've also configured the pad for liftoff. A little earlier in the count, the booster hold downs were commanded to unlatch. That means once the rocket has sufficient thrust to overcome its weight, it'll lift off the pad. There's no need to command the hold downs to release the rocket. As we mentioned earlier also, the ignition sequence has been slightly modified from the last flight for a more efficient liftoff. As a reminder, we ignite the engines a few seconds before T0. We don't lift off exactly at T0. We lift off a few seconds later, a couple seconds. Finally, the SpaceX team continues to check in with the Coast Guard to ensure there are no boats in the safety perimeter before proceeding with launch out over the Gulf of Mexico. Now, currently, we're coming up T-minus 7 minutes, 10 seconds to the test flight of Starship. Propellant loading is continuing on both stages of Starship. We're waiting now for the completion of loading of the header tanks in the next few minutes. The first stage is also beginning pressurization for flight while we are continuing to load propellant into it. And again, booster propellant load will finish at approximately T-minus 3 minutes. At that stage, both first and second stages are fully loaded, and we'll have the 10 million pounds of liquid propellant on board the 2 stages of Starship. Now, in the next few minutes, the guidance system will perform its final alignment. We'll get the automated flight termination system that'll arm, and the final TVC checkout will be performed. We may get a view looking up at the engines as we gimbal the 13 middle engines to check them out just before liftoff at about T-minus 90 seconds. If we need to hold, it would come at T-minus 40 seconds. That's the point in the countdown where we can pause to wait for final checkouts or pressurization to complete. Or, as we're hearing right now, we're still working a few boats in the area that are headed south. And a lot of cheering here in Hawthorne. The boats are heading south, but we are still planning to hold at T-minus 40 seconds if necessary.
Just amazing views of today's launch. There's nothing quite like a launch at basically sunrise. Sunrise, I think, was just about 10 or 15 minutes ago out at Starbase.
Yeah, these views are just incredible. Couldn't ask for a more beautiful day to attempt a test flight here. Again, these are live views of Starship as it awaits its second integrated flight test. Our primary objective today is to get through stage separation. We really want to test out our attempt to perform hot staging, where we are going to ignite the engines on the second stage while some of the engines on the first stage are still lit. So essentially both stages will be making fire at the same time, and that will push the booster away from the ship. It'll separate the 2 stages. So that's the primary goal for today. We really hope to be able to test that out, but at the end of the day, all and any data that we can collect is going to be incredibly helpful and help inform future improvements and iterations of the vehicle.
Yeah, Kate, there are other objectives for today too, assuming we get farther than stage separation. There's goals to test out how reentry goes on the ship portion. If the booster survives stage separation, then it's going to try a boost back burn and hopefully a soft landing as a sort of dress rehearsal for what it would look like on land. So everything coming up to that big design change, though, of hot staging today.
Yeah, exactly. Like you were saying, that booster, it will be attempting a water landing in the Gulf of Mexico. We don't intend to recover any of the hardware for either the ship or the booster today. But that booster, yeah, we want to try and demonstrate controlled ascent through most engine cutoff. We want to try to demonstrate that hot staging separation and boost backflip, trying to basically demonstrate controlled burn and entry and that soft water landing. Like you said, it will help inform when we attempt a land landing, but we start in the water first.
Exactly.
Just like we did with the Falcon 9.
Yeah, exactly. And, just getting to hot staging, though, is going to be farther than we got on Flight 1.
Yes.
Flight 1, that was about as far as we got. We didn't have hot staging on that vehicle. So that's the first and foremost objective today. Get that far, hopefully.
Fingers crossed.
Now, one thing that's a little cool about Starship, and it's different from Falcon 9, is we can actually hold a little bit longer if we needed to than we can on Falcon 9 missions. Once we get to T-minus 40 seconds, and if we did have a hold, depending on the reason for the hold, we can hold for up to 30 minutes. And today, actually, our entire launch window is about 20 minutes, so the hold duration would cover most of our launch window.
Yeah.
And that's different from Falcon.
Yeah, absolutely. With Falcon, we have to go exactly at T0. That 40-second hold is super helpful. If we need to, for example, we need more time to pressurize the COPVs for flight levels. Perhaps fuel.
If the engineers just need to look at some of the data, see how engines are performing, or the avionics.
Exactly. Those checkouts, being able to have the opportunity to top off the fuel or LOX if it's not fully loaded. And, we might want to just take a few more minutes for that. So that T-minus 40-second hold can be really helpful. But we don't have that option on Falcon. So it's a little bit different here.
We're just inside T-minus 2 minutes and counting. The good news right now we're hearing it doesn't look like we're going to need to hold a T-minus 40 second as the boats are clearing out of the way. Next event coming up, TVC wiggles as we move the center engines on the first stage. You can see maybe just a little bit there. 90 seconds, wiggles are underway as we're checking out the first stage. TVC checks are complete. Next major event we're going to hear, hopefully, is the flight director go for launch at T-minus 30 seconds. As we're coming up on T-minus 1 minute, when we get to T-minus 40 seconds, we'll just listen in. Last time, as you recall, we did hold at 40 seconds, but it took a few seconds for the clock to recover, so we're going to watch that. And as we press to T0, we're going to watch and listen the second test flight of Starship.
T-minus 30 seconds. Back to rapid recycle.
Back at Hawthorne, we're at T-minus 40 seconds in holding. We had a rapid recycle. We've not heard anything over the countdown net as the team works both first and second stages. We're going to monitor the nets here for a minute. Got a little bit of an update. We're continuing to hold at T-minus 40 seconds. This is the normal hold point for Starship, as we talked earlier. Sounds like we're working just late pressurization on, I believe, the second stage. Team is working it. All the other systems are on hold right now at 40 seconds. We can hold here for about 15 minutes or so before we would run out of window for this morning. So right now they're working on filling pressure vessels. And ideally we'll be able to solve this and come back and release the clock at T-minus 40 seconds. We're going to continue to listen and monitor for another few minutes.
And it's worth mentioning here that don't go away. We are holding at T-minus 40 seconds, but once the teams have resolved and see the data that they want to see, the clock can restart straight away, and it'll start ticking down from T-minus 40 again, all towards liftoff.
Yeah, exactly. Now, while we do have the ability to hold for up to 30 minutes, we only have a 20-minute launch window, so don't go away, don't change the channel. And just like Shiva said, we can restart that clock, and there it is.
And there it goes.
Clock is rolling. T-minus 30 seconds. T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff. Vehicle pitching downrange.
Chambers pressure nominal.
We are T-plus 40 seconds into the flight of Starship. 33 Raptor engines powering the first stage.
Power and telemetry nominal.
We've heard power and telemetry nominal call out. We're heading downrange over the Gulf of Mexico. And that call out tells us Starship is through the period of greatest stress on the way to space. Now the next major event is hot staging in just over 90 seconds from now. To get ready, the booster will shut down all but 3 of the Raptor engines. Clamps holding the 2 stages together will release, and the Starship's second stage will ignite its engines. Starship will then separate from the Super Heavy booster and head to space. And at the same time, the 3 engines that are still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on path for a splashdown in the Gulf of Mexico. Engine power continues to look nominal on 33 Raptor engines. We're about to shut down the first stage and perform staging. Let's watch and listen.
And acquisition of signal Houston and New Orleans.
Booster engine cut off. Stage separation.
Boost back startup.
Starship engine ignition.
You're hearing the cheering. The first ever successful hot stage for SpaceX's Starship.
Incredible views of our Super Heavy booster. And as you can see, the Super Heavy booster has just experienced a rapid, unscheduled disassembly. However, our ship is still underway with all
avionics,
6.
power and telemetry nominal.
And we just heard there, ship avionics, power and telemetry nominal. All 6 engines are lit, as you can see from the GUI there at the bottom right-hand side of your screen. Now, we did know that the that hot staging was going to be incredibly dynamic. We knew that there was a chance that the booster would not survive, but we're going to take that data and figure out how we can make the booster better for the next hot stage.
Yeah, that hot staging put a lot of load on the top of the booster, and of course it flipped around there, a lot of dynamic stuff happening. But ship is still going strong.
And it's doing great. Right now, the ship, the second stage, is on its way. Like we said, you can see all 6 of its engines are ignited. The next major milestone for the ship will be the shutdown of those engines, or SECO, second engine cutoff, which if you follow our Falcon 9 launches, familiar terminology there. So far, today has been incredibly successful, even with the RUD of the Super Heavy booster. This is amazing.
Primary objective of the booster today, to get to hot staging, to get ship on its way to orbit. It did that admirably.
Yeah, we definitely asked.
Starship trajectory nominal.
All right, great news there. That trajectory for ship is
Acquisition of
nominal.
signal, Cape Canaveral.
Once again, Starship's second stage is firing those engines. And as you just heard, everything's looking good. Now, for the ship, we wanted it to survive hot staging, which, as you can see there by that little dot on your screen, it did. We also want to basically demonstrate that the successful startup of those engines, demonstrating controlled ascent, which is what it's doing right now, and eventually orbital insertion. We are hoping to basically send this around the Earth, and if it makes it this far, splash down in the Pacific Ocean, a couple hundred miles north of Hawaii. Now, if we get that far, like all of that sounds great. Secondary objectives for ship, again, continuing to gather engine data and about its health, performance.
Nominal ship chamber pressures.
Great news there. That tells us that the chamber pressures inside of the Starship, again, that's that small dot on your screen, basically the propellant pressures in the ship are looking good.
Yeah, the bottom right corner of your screen, you can see essentially a user interface showing us which engines are lit. So the 3 center sea level Raptor engines on ship are gimbaling engines. The 3 outer engines in the triangle, the larger ones, are Raptor vacuum engines. All of them continuing to fire nominally. So they're at the pressures that we expect to try to get into our target trajectory today.
Yeah.
And we're not targeting orbit today. We're targeting almost orbit today. That's very intentional as part of the mission design. The goal is to get to a thrust profile similar to what we would need for orbit, but also
And
to get to the
expected
energy
signal,
levels
Houston.
that the ship would need to dissipate for re-entry. And so we're actually going in a suborbital trajectory today, but that trajectory will get us to the energy levels that we need at re-entry, where we can really stress that heat shield and get valuable data on re-entry. And those calls that we are still on a nominal trajectory here and seeing nominal pressures means that we have a really good shot of hitting our target orbit.
Yeah. Now, if the booster had survived, we would be around the time where it would be getting ready to land, performing its re-entry, but it unfortunately did not survive. That being said, that's okay. It survived several seconds after hot staging. So we're going to take that data and improve the hot staging sequence and probably improve the hardware itself for the next flight.
They're standing by for a call out here. Coming up on the projected time that ship would shut down its engines.
As you can tell by the excitement from the crowd here at Mission Control Center in Hawthorne, there's a great view of our Star Command Center. That's our control center at Starbase Texas. The crowd here, Mission Control Center behind us in Hawthorne. Everyone is super exciting. What a successful day this has been so far.
And I mean, up to this point, major successful milestones through hot staging, which was the big objective today. So we are going to head into the coast phase, planned for the next about hour and 5 minutes. We'll be returning around the T+1 hour and 15-minute mark. And that's while we're waiting for Starship to continue on to its next step for reentry. We're not totally sure what video we're going to get, and that video comes normally by overflying ground stations, but we don't have a ton along our flight path. So fingers crossed that we will get some via Starlink on this mission since we're testing that out. And also give us a moment. We are hearing some chatter on the net, so we're going to try to parse that for you.
John Innsbrucker back here in Hawthorne at our webcast desk. We have lost the data from the second stage. We had heard a call out that we were internal guidance, which means we were getting near the end of the approximately 6-minute burn of Starship. But we haven't gotten any more data since then, so we think we may have lost the second stage. So we would not be into coast phase. We wouldn't be able to come back in an hour or so and possibly get ready for reentry. However, what we do know right now is we had an on-time launch at 7 o'clock. We got through the boats. First stage looked beautiful with 33 Raptor engines firing. We got the hot staging, you know, the thing that we really wanted to see and impressed. We saw the separation. We saw the flip maneuver. We saw the light up of the 6 Raptor engines on Starship, and it headed away. Everything really looked good. But what we do believe right now is that the automated flight termination system on second stage appears to have triggered very late in the burn as we were headed downrange out over the Gulf of Mexico. But the real topping on the cake today, that successful liftoff, Kate, Shiva, the hot staging is just beautiful. Exactly what we were looking for.
Yeah, ultimately, what honestly such an incredibly successful day. Even though we did have a RUD, or a rapid unscheduled disassembly, of both the Super Heavy booster and the ship, that's great. We got so much data, and that will all help us to improve for our next flight.
Of course, and that's why we flight test, and you can bet that there's going to be more to come. So we really do want to thank you all for joining us. Of course, we want to thank the people of Cameron County. We want to thank all the federal agencies that have supported us for our test. And of course, a huge congratulations to the entire SpaceX team on getting through this flight test today. And I think with that, we're going to sign off from here in Hawthorne.
Thanks so much for tuning in, and we'll see you next time.